Okay. Week 5, we're almost halfway through. Next week's the midterm break. And then we have another 5 or so weeks and then we're done. Crazy. So today's lecture is a bit of a moment to take a breath because you should be in the midst of assignment 1 now. How's assignment 1 going? I don't know how that you meant to answer this. How fun is the assignment though? Like Sokuban. It's great. And has anyone seen the graphical versions at the end that you can do? It's really cool. So yeah, you're in the middle of it now. So that's really good. So what I thought I would do with today's lecture, because we're running pretty good on lecture pacing, is to talk about 2 things that I would say aren't critical. Important, but not critical. But it's mainly, I'm just not going to introduce a really important new concept this week so that you've got a bit of a moment to focus your limited energy and resources on the assignment content. Does that make sense? So still important stuff. So two things to talk about. And then I thought I would just jump in and talk more about the Connect 4 program from last week, because that's all content relevant to the assignment. But then on Wednesday, it's a really important topic. So I'm gearing you up now, okay? And Tammy's not here actually, she'll be here in a second, but she's giving the Wednesday lecture. So that's the plan for this week. The next week is midterm break. So it's a big moment to take a breath and focus on the assignment. And then pretty much we'll be running into assignment 2. Cool? So we're not slowing down, but we are trying to pace this out. So something important to me that we can start talking about to get started nicely into this week is style. So code style, code quality. What we're talking about here are aspects of code that aren't related to the performance or the what the code itself does, but how it's written. And what we're really focusing on here is how it's written so that we're able to communicate efficiently to other programmers or to ourselves. So this is really simply a C program that's written in really bad style. And we haven't, spoken about some of the technical terms for why this is bad style. But if we look at this code, do we think it's good style or bad style? And the thing to put a finger on here is, what about this screams bad style? So only a few weeks ago, most of you have never written C before in your lives, right? How many of you was that? A lot of you. Now, just a few weeks in, you're looking at this and you're not only saying, yeah, that's a C program, but it's a bad C program, right? So what about this, just yell out some answers. What about this screams bad style? Vague variable names, exactly. You? The order of the functions, that seems okay to me. What would you do? I always put main at the bottom, actually. I think some of the tutors and admins and stuff do write it so that main is at the top. Is that in the style guide? It is. Well, things are subjective, as we will talk about in this lecture. Tammy, are you okay? Oh, that's fine. Oh, Tammy's best. Tammy's giving the Wednesday lecture, and it's probably one of the most important topics of the course. So, do you want to introduce yourself now or next week? I'm throwing you under the bus.
Oh wait, is that you?
Oh no, that's okay. Anyone have a USB-C to C cable? You know? Okay, don't back down after you put your hand up. All right, I just want to get the lecture chat. Yeah, just throw it. Oh, that's community. All right. Tammy, do you want to introduce yourself very quickly? There's a mic. Wait, they can't hear you online.
I'll just.
No, they need both.
I'll just talk straight. Hi, I'm Tammy, and I will be taking the lecture on Wednesday.
Why are you taking the lecture on Wednesday?
Because Jake is amazing, and Yeah.
That's not the answer I was fishing for. But
Oh.
so anyway, Tammy's a PhD student. She's also a course admin, and she's
But Jake is amazing for allowing me to take the
no,
lecture on Wednesday.
and she's going to take the lecture on Wednesday. So very exciting. You'll see Tammy on Wednesday for the pointers lecture. Very important topic. All right, thank you. All right, sorry, this is a bit chaotic. What were we talking about? The order is okay. I'm okay with the order, but you are right.
Just functionally, will it run if it doesn't have return 0 at the bottom?
Okay, it's missing return 0. Actually, it will run without a return 0, but it won't necessarily return 0, which indicates a problem. But it will do the same thing, actually. But it's still a bad example of code. Yeah, it's not intuitive. It's hard to understand. It doesn't have comments where we think it might need to have comments and things like that. So this is, remember I spoke about this idea of code smells, things that we look at that seem wrong even though we might not have an exact term for it. The other thing is, has anyone actually figured out what this does? No. So even though code style we said doesn't affect what the program does. So if this program was rewritten with good names, good style, good standards, you would instantly know what it does. It's actually very obvious. But without those properties of good quality, no, has anyone in the room figured it out? No. So that just goes to show how important code quality is, right? Even though it doesn't affect the output of the program. And it's one of the things that makes programming hard. Programming is setting out a list of instructions to achieve a goal, right? But this program does that. It achieves the same goals, but you're also communicating to other programmers. So someone sent me an email this week or this weekend asking for a book recommendation. And I really don't recommend programming books very much, but this is a book that I do recommend. It's called Clean Code by Robert Martin. I don't know, we're live on YouTube. Find it, pay for it on Amazon or something, right? No, it is a good book. And it talks a lot about, it's probably more relevant to you if you're in, say, a 1531 software engineering course. But if you're really keen, you could get started looking at it now. And it goes into a lot of detail about lessons learned about clean code and things like that. It's not entirely perfect. It's not a Bible, but it's interesting. The other thing about style is that it is subjective, right? So I've been writing code longer than I've been teaching here at UNSW, and there's things that I do in my personal sort of preferences for code style that is a little bit different to the course. But what's really important is that you follow, right, your employers or your, in this case, your course's style guides. So style guides, some components are pretty much agreed universally on what's good, like good variable names. Some things are subjective. For example, where do you put braces? But what's really important is consistency and following the style guide of your institution. So everyone has seen the 1511 style guide? Has anyone not seen it? If no one puts their hand up, I won't show you. Has anyone not? Okay, yeah, there's the honesty. So on the course homepage, there it is, style guide. And you can read all about the different rules and recommendations that we provide to you. What's really important is if you go down to illegal elements, these are things that if you do them in the course, for an example, an assignment, you will lose style marks. So these are the things we're really strict on. I actually think these are pretty inoffensive, so nothing here is going to really cause an argument. Then we have rules to features to avoid. And these are things that we prefer you don't do, but there's a bit more nuance about them. So there might be a case where using one of these features is appropriate, but really what we often see is that students overuse these features and it is an issue. So if you're really experienced and you're saying this is a silly rule, it's not about you, it's about people building good habits from the beginning. So the common ones are break, continue. Yeah, they're the two ones that I see a lot. Maybe switch statements and stuff. But yeah, otherwise you can, whoops. What? I don't know what I just did then. Otherwise you can go through and read our 1511 style guide. Okay, I just want to get the YouTube chat up while we do this. What? Okay. All right, so let's take a look at this program again and improve it so that we can figure out what it's doing. How does this work? Does the next slide? No, okay. So I'm just going to copy this into my text editor. Messy code. So actually I was missing a semicolon there. That's a bit of a problem. All right, so let's start at main. That's where I'm typically going to start. All right, so the first thing is that this thing is called struct thingy. That's an awful name, right? So if we go to the struct, we have to figure out what it, well, I know what it was because I wrote it. So I'm improving some components of this and the rest will fall in. So the first thing is that we got to rename this thing thingy. And actually what I intended it to be was, I think it was a Pokemon. And I think X was the HP and double was the attack. So X was the HP and double was the attack, right? So already with that change, we pretty much have a clearer. Yeah, that's missing, but let's get there slowly. Yeah. So is X a good name for a Pokemon? No. I don't know what Pokemon it is, but we can just call it my Pokemon. And X changed to HP, Y changed to attack. And we assume that the values are right. And then, yeah, you can see now it's really clear that we're missing a second Pokemon. That needs to be HP, that needs to be attack. So we're creating two of these structs called Pokemons, assigning them some initial values. Then we've got this calculate result function, which again, is that a good name or a bad name? It's pretty bad. What calculate what? It's so vague. What is it doing? What is it calculating? So these, exactly the result. So these are the things when you're writing functions and naming variables, be really simply clear what exactly is this function doing. Has anyone figured out what it is doing now? Yeah, it's two Pokemon attacking and then it's figuring out the remaining HP, I guess. Or it's figuring out which one won. Right. So what would be a good name for it? Yeah, battle, attack, yeah, Pokemon, attack, conflict, yeah, attack. It's a battle, right? I like that. Battle two Pokemon. We need a return type. That's, oh, I also need to spell better. It looks like it's returning an integer, right? So then all we need to do here is fix this. Pokemon A, this would be Pokemon B. You can see how annoying it is to do this. No. And then this needs to be, X was HP, right? Yeah, but I don't know if it's, the question was, is there a find and replace function? And there is, but I don't know if my thing is set up correctly. That was a mistake, by the way. What was I doing? X. And then Y was dot attack. And then X was meant to be Pokemon A. Right. So now with those few changes, we spotted a few bugs, we made things really clear. And if you closed your eyes and opened them and glanced at this program, right, it's pretty obvious what it's doing. So that was just to demonstrate the importance of code quality. You know, when you're working at a really large organization, you're in your first internship at wherever it might be, CBA, Canberra, Atlassian, and you're given code, you want to be productive. You want to solve the problems that you're being tasked to solve. And it's really hard to do that if the code quality is not right. So when you're writing code yourself, you want to make sure the code quality is good. Cool. So that was just a mini little lesson on code quality. So do always think about it at the back of your head. Any questions on style or code quality? Anything from the chat? Why can't I figure out this? I'll do that later. All right. Okay. So a bit more of a, maybe not interesting, but a real programming topic is command line arguments. Now, I forget where we left this. So so on this topic, command line arguments, it's not a core topic of the course. So for example, it won't be in any hurdle questions in the exam, and it's not in assignment 2. But there could be high-level questions in the exam that rely on command line arguments. So what are command line arguments? So if we write functions in C or any programming language, we can pass data to the functions, right? And when we pass data, the receiving end, we call those parameters, and the passing end, we call those arguments. So here's a function called cool calculation, another really bad function name. And how many parameters does it have? Someone say 0? It's got 2. What are they called? Int x and int y. So if when I call this function, I need to give it 2 integers, x and y. And those are the input to the function, or arguments. Right? So why are parameters or arguments useful or important? Can we throw out some answers? Why do we need arguments? To specify a task? I don't know about that. Who's talking? Where are you? Oh, save time? I don't know about that either. To put something in? I mean, a bit vague. To allow the user to provide information he or she may want. Let me correct. I don't know if this information is coming from the user. The information's coming from within the code. So it could be data that comes from a user. That is a good use case of parameters. But I wouldn't say it's information from the user necessarily. Anyone else want to throw something out? I think it's worth getting a precise answer here. One last go. To make it reusable, yeah, you're getting at something a bit better there. But the way I would answer it is, what we're doing here is we're allowing some input to influence how this function will operate. So some tasks require additional information, right? So if I ask you to go and open a door, so open a door, open one door, what information do you need from me? There's 4 doors. Which door? So that would be a parameter. In order to achieve that task, you need to know a bit more information from me. So in the brackets of that task, it would be like door, you know, which door to open, right? Now you're right, whoever said it over there, sometimes that information came from the user. So maybe the user entered the door, but it doesn't really matter. The point is we've got this task, this function that can open a door, and we need to know extra information. Similarly, if your task is to tell me the weather on a particular day, what do you need? Yeah. If your task is to calculate the sum of two integers, what do you need? Integer A and integer B. Exactly. So some tasks inherently need extra information. That's one use case for parameters. Sometimes, for example, there could be multiple ways of doing something, and you need to specify which method you would like used. So you could use a parameter to tell. So it's just extra information that the function needs. And we can use those parameters to alter how that function operates. So for example, if I have this cool calculation function, which I don't know what it does, if x is positive, do something else, right? We're modifying the flow of this algorithm based off the values that are passed in. So that's really important. All right. So the question then is, so that's arguments and parameters, so there's nothing new there. That's just a recap. The question is, what about our entire program? So when you compile a program and you run the program, it always enters into main and it always does the exact same thing. So command line arguments are pretty much the simple way to think about them as like function arguments, but for your entire program. Does that conceptually make sense? So you're giving a little bit of input into your actual entire program. Now, interestingly, who's used command line arguments before? So who hasn't? Everyone else then? You're all wrong. You actually have. When you run the program CD, you know when you change directories in the terminal? You do CD space, what do you give it? The directory you're moving into. That is a command line argument into the CD program. What's just going on down here? It sounds like a bomb's about to go off. I don't know. So CD is a program that someone's written, and you were telling it how to do something. You're okay? We're okay? Okay, I don't know. And similarly, you might want to create a program that the user, when they run your program, gives you some extra information. Like maybe you want to write a program like CD. So you actually have all used command line arguments. You just have not written a program that can have custom command line arguments. Okay, so that's what we're going to look at with command line arguments. So I suppose this is how we might do something like let's say you were building the change directory command right now without command line arguments. You do have a mechanism of getting the directory from the user. What would you do? I mean, the answer's on the slide. I keep doing this. But you could do a scanf, right? So you could run the program, and then you could say, oh, which directory do you want to move into? But it just adds a bit of friction because the user already knows where they want to go. Like, just let them tell the program. So you could do scanf, but that's not always nice. And maybe we don't want the input to come from a user. Maybe the input comes from another program that calls your program. So that can't enter really into scanf very easily. So what we can do, which is really cool, is modify our main function, which is the entry point of our program, so that's not changing. But rather than accepting nothing, the entry point main accepts two special parameters, argc and argv. So who can tell me what maybe they stand for? Let's finish who can tell me what they stand for if you just were to guess? You know? Yeah, okay, well tell me. Argument count and? Ah. This better be a good guess. Do you know what it stands for, argv? Not argument variables. Not argument, what? That would be E, wouldn't it? Good guess. Sorry? Yeah, vector, very good. Why is it vector? You don't know, you just... I like the Odyssey. So sometimes we call dynamic arrays vectors. So if you, yeah. So basically think of it as an array, but it's dynamic in that the size of the array can always change. This is actually a topic we haven't covered yet, like the general concept here, but all you need to know for now is that it's an array of things. So the argument count and the argument vector. So we're being told how many additional pieces of information were passed into main, and then we're told what are they, right? What's the actual list? So by making that change, we can accept argument vectors. All right, so that's a bit theoretical, so let's just jump into a program here. Is this too small, maybe? Whoops. Is that too small? Can we all read that? Good chat. It's okay at the back? And online? We're okay? Okay, good. All right, so int main, instead of, we miss our void friend there, but void's gone and we get int argc, int character. Well, we haven't really spoken about the terminology here. What this is a piece of memory that contains an array of character arrays. So it's an array of strings, basically. Let me annotate this. Int argc, that's easy. Argument count. An array of strings. And because strings are an array of characters, it's an array of characters. Does that make sense? A few blank stares. It'll make sense when we use it, I think. And that's the two pieces of information that allows our program to have parameters.
Is the star, I suppose the asterisk, is that specific vector notation?
No, vector's not a real thing in C. So it's just the terminology here. The asterisk, again, Tammy's going to introduce it on Wednesday. The asterisk means a memory address, but it's how we represent an array. It's one way of representing an array. It'll make more sense on Wednesday, I promise. Okay. What's this program going to do? It can just print out the arguments for now. All right. So when we're dealing with command line arguments, we need to be careful about something. So let's say this is a program that prints out its command line arguments. So if the program is called program, and then we give it like hello, what would it print? Sorry? What would it print in this example? Hello, because hello was the argument. Right? Did we see that? Like when you go change directory and you give it the directory, it changes into that directory. When you call this program with hello, it just prints hello out to the terminal again. So, but here's the trick with command line arguments, okay? You cannot trust that the user remembered to enter in the command line argument. Like what happens if I go to my terminal and I go cd, but I forget to give it an argument? Well, it has to account for that. Right, I could forget. Maybe if I do make directory and I forget, it tells me, oh, there's an error there. You've not given me, it has to look, because a user could very simply forget to provide an argument there. So we can't trust that an argument was provided. So that's one thing we need to worry about. I'm going to put this here. Okay. So the first thing we need to do if we want to check that the data was provided to us, from those two pieces of information, what could we look at to check that we were provided command line arguments? Scanf isn't going to help us here. So scanf is what's your name actually? Jay? That's what Jay yelled out, scanf. Scanf isn't, we don't need scanf. argc. We're told a count of how many parameters were passed. We're being given that information. So we can check argc. The problem is if we checked argv, what could happen? So if I tried to get hello out of argv, but it wasn't passed in, what would I be doing wrong? Do you know? The green jumper? You gave your answer and then you were like, that's my job done for today. So you said we could use argc, right? But why do I need to check argc? Why can't I just go into argv and take out, for example, hello? It might not be there. If they forgot to put it in, it's not going to be in the vector. And if it's not in the vector, you'd be reading memory you're not allowed to read. Right? So we can check argc. So in this program, how many parameters do we expect? 1. You're saying 1? Right? We want 1, let's say. We don't know what to expect. We want 1. Let's just do like, yay. 1 parameter passed. All right. So let's compile this like normal, arguments dash out to program. So I run program, but this time I'm going to pass in my command line argument hello. What do we expect to happen here? So what should be printed? Who thinks it's going to be printed? And who thinks it does it? It's not going to be printed? It's not printed. Why is it not printed? We're printing the string here. This is what I want printed in this case. So this if statement isn't triggering. Anyone got a guess as to why? Yes, very, very good, very good. What's your name? Luca. So Luca just said the first argument is actually the name of the program, which is correct. So there's actually 2 parameters here. So it's a little bit weird because I kind of get why people get confused here because program is not an argument, it's the thing we're running. But it's also treated as an argument. So actually, to prove that, why don't we just do, and something is wrong with my formatter. I'm going to just give up on this though, but printf, there are %d parameters. And let's just print argc to see what it is. And it's 2 parameters. That's what I meant to do there. There are 2 parameters. So the 2 parameters are program and then hello. So that's why this wasn't triggering. So if you want 1 parameter into your program, you need to check for 1 plus 1, right? If you want 2 parameters passed in, you need to check for 3. Or you want a minimum of 3. Is that a hand? No. Tim? No. Okay. Does that make sense? Yeah, good point, good point. If we run program like this, we will get the parameter passed out. Because now there's only 1 parameter. And, in fact, we can print what that parameter is. That should be right. Oh, yeah, thank you. See that right there, let me just do another. We've actually taken that parameter and printed it back out, and we can see that it's /program.
If argc is of integer type, how is it taking in a string as an integer or as a parameter? You're typing in instead of char.
So argc only stores. So the question was, if argc is an integer type, how is it storing the parameters?
How does it know that a is a different parameter than b if you have
Ah, I see. Good question. Okay, so the question from Jay, right, is if when you run this program, what you're saying is like, whoops. I mean, let's look at this program invocation. This is calling the DCC program. And how many parameters are we passing here? 1, 2, 3, 4, if we count DCC itself. So the question is, if this is one string, how is it being broken up into 4 parameters? Is that roughly your question? Because argc is of the type int. But let me just quickly say, all it's doing is looking for the space character and splitting based off that. So if it sees a space, what came before it is 1, and what comes after, if there's a character after a space character, then that's now the second argument, and it's just counting how many times that happens. It's looking for spaces. Well, it's doing what we would call a split. So it takes this string, and then it's splitting on the space character. So it finds all occurrences of the space character and then splits it into an array. Okay, good question though. So yeah, okay, so if we run this program like this, we see that we get one parameter out and we have the name of the first parameter.
What does the asterisk really mean before arg?
Okay, the question is, what does the asterisk really mean before argv? So we haven't covered this yet, you will learn it on Wednesday. The asterisk means a memory location. So it's the address in memory where that vector or that array starts. That's the answer. That may or may not be useful. Question up there at the back? You? No, that you're stretching? Okay, cool. All right, so this was fun, but not that useful because we wanted our hello parameter to be printed out, right? So what could we do here? Well, first of all, before we just grab out argv of 1, right, which would be the second parameter, we want to make sure that it's there. Everyone agrees with that? Yes? So what I can say is if argc, we could say greater than 1, whoops. Now we know a second parameter must be there. And then I can just print f, no, in fact, I'll just do this. I might just, do you want me to delete this or keep it there? What's better for your notes? Keep it? Now hello gets printed out. Yeah, there are 2 parameters, program and hello. And I'm printing out only not the 0th argv parameter, but the first one, which is the second one. So hello gets printed. Cool. So that is pretty much command line arguments. Now, for example, you can do something with that hello. Another thing you could do is, for example, you could have that command line argument to be an integer, convert it to an integer, and then do something with it. It's just a variable in our program that you can do whatever you like with. I want to show you one more thing. Let me copy all of this. Oops. Command line arguments 2. We delete that. I'll keep that there. I'm going to keep that, and I'm going to delete this. I want to just show you a common way that we deal with command line arguments when the command line arguments themselves is not static. And so what I mean by that is, like if a good example of this is looking at DCC. There's many, many, many ways to run that DCC compiler program. I don't actually need to give a -o program. Why is it .c? Anyway, what will this compile it into? A out. So do you see how sometimes you need 2 parameters, sometimes you might need 4 parameters? It's very dynamic, right? Which is pretty common in more sophisticated programs. So a really common way to figure out, sort of what I'm dealing with my arguments is by using a loop, to loop through over each argument. And we can pretty much simply say, int I equals 0. Oh my God. While I is less than argc, print f puts argv of I didn't forget. So this is a really common pattern when we're dealing with command line arguments. And by using that argc as my loop counter, I can iterate over each argument and check what it is, print it out, do something with it. In this case, we're just printing it out. And the nice thing about it, now it's not called arguments. What was it? CLA2? The nice thing about it Oh, I didn't. Yeah. So I just forgot to add one to I there. So no matter what I pass in, right, we iterate and access each of those parameters. And then I can do things like try and understand what it was that was passed in. Is it a valid invocation of this program? And I'm getting all that information passed into my program to understand what to do with it. So looping through our argvs is a pretty common way of dealing with when we've got a bit more of a sophisticated program, something like a compiler, where we get variable information being passed in and we don't know what to do with it necessarily. But when you're dealing with a program like that, you can think how dynamic the DCC program is. You've got to really make sure that you understand what's being passed in and you can validate it, check that it's all accurate, and do what you need to do with it. So that's it for command line arguments. Any sophisticated program that you run is more or less going to have some sort of command line arguments going on, even if you don't necessarily interact with them. So it's a really common way of providing input into a program's invocation. Any questions on command line arguments? So like I said, it's not a core topic of the course. It used to be, and then we took it out. But then we thought it was really interesting and relevant, so we've sort of put it back in lightly. So if you're looking to pass or get a credit in this course, you're not really going to run into them again. If you're going for a distinction or a high distinction, there could be some extension questions in the exam that make use of this information.
Where are the slides for this? I put all the slides on.
I updated them, so they should be there now. So the question was, where are the slides for this? You're right, there was a mistake with this week's, this lecture's slide.
Ways to include the actual program in the count. You want to extend the program. Is that why? I'm betting to the entire.
Good question. Okay. Jay, third good question of the lecture, I think. So Jay asked, when we ran this program and I gave it like 7 additional pieces of information, why does this get passed in as the first argv? So what's the point of passing this in? The answer is, so I've actually never written a program that takes that utilizes this, but I can give you an example of ones that do. So, for example, DCC is a compiler, but it's a program called DCC, and it needs parameters to do its job, right? So the source file to be compiled, the name of the output, you get the idea. And then what happened is we took, so DCC, remember I told you we built it here, and then I was in New York, and I was talking about DCC at a seminar at a university there, and they were like, that's really fantastic and really cool, but we teach C++, right? Can you make a C++ version? So we made a C++ version. Now you've got a question, right? C and C++ are overlapping languages, so all C is C++, but not all C++ is C. So they're very similar languages. C++ is an extension to C. So you've got this case where, okay, we want to write a C++ version. It's not actually a huge amount to add. So do you write a whole new version of your compiler called D++ or something? Or can we use that same program and then have our additions added to it? Now that was simpler for us. So then what we did is we made a symlink to the DCC program called DCC++. So it's the exact same program, but it's got a different name. But if that program's executed, I know I'm in C++ mode. So I can check argv of 0 to see which of my two binaries was executed. Does that make sense? That's a concrete use case. Did that make sense to anyone, or was that a bit too in depth? So it's just basically like, all it is like, I can copy program to like special program, and then when I run special program, I know that my special program is ran, and I can do something extra here. Like, in fact, why don't we really, that could be cool. So if argv of 0, so that's the thing there. How do we compare two strings in C? Yeah. What's wrong with this? Oh, missing a bracket, and I need to include now. What's wrong with this? Integer to pointer conversion, passing it in. Oh, thank you. That makes sense. Then I need to copy it over. So if I run program, I get that. But if I run special program, I get my special mode activated. And it's kind of, it is useful in some rare cases. Yeah, you could have a special Easter egg. I mean, it's not the reason why this exists. Basically, some programs are probably okay, another example, I don't know if this is true, someone might want to correct me, but copy and move, CP and MV, they're very similar programs. One copies the file and moves it, like duplicates it and copies it. One cuts it and copies it. It could be that they are the same program that do something with argv of 0 to check which way they're being run, right? Because 99% of that functionality is common. Someone maybe want to check that they do that, or I don't actually know, but it could be something that they did. Okay, that's enough time spent on that. Do you want to break now then, Kahoot, and then finish off? Yeah. All right, cool. Go for it. Okay. I got the lecture chat up online from online now. Let's see what you're saying about me. Did we ever figure out? Oh, I got it working. Is that going to break something with online audio? Sorry? Oh, they won't hear this. Oh, that's fine. Yeah, you're right. But so they don't hear my internal mic's output. That's fine. That's good. I've always missed the music. What's this? This is new. Oh, you can scan a QR code. All right. Is everyone joined? Anyone need a minute? All right. We're starting. Once again, don't at me if there's anything wrong with these Kahoot questions. All right, what is the value of argc when the following program is run? God, we're getting straight into it. Oh, easy. Too fresh. What is argc? I like that one. Yeah, very good. We just covered it. argc is the first argument. Sorry, program is the first argument, therefore it counts. And I definitely remembered the Pokemon cards this week. Okay, which function is used to access command line arguments? This is an interesting question. You can come in. You can. I think the wording is a little unclear, but the command line arguments are injected into main, which is what this question is trying to understand. Radiant Badger on top, Genius like. Okay, how are the command line arguments separated in argv? Yeah, by white spaces. We spoke about this. Well, there's no commas in a variable anyway. But there's no comma. So we take the command line arguments, separate them by the white space character, and those go into argv. Aren't entries in an array separated by a comma? No. Where's the comma stored? There's no commas though. There's no commas anywhere. Anyway, what function is used to convert the cards taken from the command line? We haven't actually covered this yet. Get wrecked. Good luck. I don't know how this happened. Yeah. I mean, I think it did pop up on the slide very briefly. What's it stand for again? ASCII to integer, yeah. Whoopsie. This isn't going to be good. Question 5. Okay, this one we've got. What is argv of 3 in the program Zuko Ang Iro Toph? Okay, I didn't make the Kahoot. Don't sue me. What is it, 1A? Double A. Oh, it's wrong there. I see. It's right there. Yeah, 0, 1, 2, 3. Remember, program is 0. But most of you got that. I guess if you did 1, 2, 3, you would get Ang. All right. Whoopsie. I'm gonna get destroyed over this Kahoot, I can tell. You know what? This is a life lesson to you all. Sometimes life isn't fair. How did you all get that? How did you get that? I'm on to you guys. There's a cheating ring going on with these Kahoots. Honestly, on top. Final question. Oh God. What is the output on line 11 if the program was run like this? This is, yeah. What, this is... Yeah, so anyone know what this is doing? Who cares? Someone got it wrong. Yeah, it's getting the average. It's getting the average of the arguments. But most of you got it. I'm actually very impressed. We start at 1. Why? Because we want to skip program. So now we're just getting the actual arguments if we start at 1. We add them all up and we convert ASCII to integer. to get the integer representation of those values, and then we divide by the number of non-program parameters to get the average. Is it really? Okay, well, you know what? Sue me. All right, anyone in the room? And where's that other guy that was last week? You? I got the Pokemon cards this week. Anyone else? Do I owe a you know, and I'm not even going to remember. So if you just have confidence and come down. Whoops. Or I've got Hong Kong dollars. You can have your pick. Everyone? I don't think I've got enough. Maybe on the last week.
Oh, do you want my sign?
No, I remember you, no. Okay, wait. Was any of you on a Sleemer?
Oh, honestly, yeah.
Oh, okay. So what I usually do is I give, well, there's how many of you want? Oh, no, that's not fair. I give you a pick of 3, and then the second person gets the second pick, and then, but let's do it over here, because then we can, oh, no, we don't do those energy bullshit.
I'm also like third on the fun.
Guys, you're getting 2. Jesus, I'm going to go bankrupt. All right, let's go over here. All right, on a Sleemer first. So you can come and pick from these, like, 5. Oh, that's, again, not a card. Okay, pick from those. You just pick one, whatever the one you want. What did he get? All right, show the camera. What is it? What is it? Zorua. No idea what that is. Congratulations on a Sleemer. All right, who was, what did you come this week? Third?
I was last week.
Last week. Okay, you're third. You can come and pick from these 3. Porygon Z is one of my favorites. Take it. Or you pick what you want. All right, Porygon Z there. What did you do? You came third.
Yeah.
Congrats. Come. Let me add more.
Who's the dude who knew about Pascal?
Oh, Pascal. Okay, you can get your pick of 4 then. What'd you get? You gotta show the camera. What is it? Litwick. That's a good one. Oh, the camera's there. Tim's meant to. Oh, we don't have the camera. Turn the camera back on. Yeah. What'd you pick? Why are the 2 the same? Roselia. Nice. Do I owe anyone else Pokemon cards? No? Good. You know what? Sue me. I don't know. Another time. All right. All right, online chat really liked the avatar references. Once again, I am so important. Do you think I've got time to write Kahoots? I did not write them. I wrote them like 2 years ago and they've been modified since. I'll double check. Actually, Tammy will double check the Wednesday one. That's good. Okay. Remember, the Kahoots are just for fun, sort of. All right. Stop me if you've seen this. How would you turn a string to an integer? You could use ASCII to integer. But no, let's quickly talk about it. So in the standard library header files, stdlib, we get a bunch of useful generic functions that help us do common things. One thing that we really like to be able to do is convert integers that are stored in a string to an actual integer type, right? So if I have the string number 5, how can I convert that to the integer 5 so that I can actually do mathematical operations to it? So you can see that this is a really useful function. So you call ASCII to integer, you pass it the string, and it returns back the actual integer, if it can. Right? Because you can pass it any string. So you could pass it a non-numerical string, and something will go wrong, probably an error. And then also exists ASCII to long, ASCII to float, ASCII to long. Any questions on those? Ooh. Do we need to see a demo, or is it pretty straightforward?
Well, if there's like a space character before
If there's a space before the integer, I can't remember. Worth testing. Do you want to test it? So let's just do that first. So what do we expect that to print? What do we expect this to print, guys? Oh, the fifth ASCII character, not quite. I think the name of the function has thrown you off there. The integer 5. That's good. But I know it's actually an integer, A, because I'm doing %d, but I can do mathematical operations to it. It's actually an integer. Whereas I can't do string 5 plus 5. So that works. Now then the question was, what if I had something like this? Is that right? Yeah, okay, it trims the white space. I didn't actually know that. What if you had something like that? My bet is that it can't convert it, so it leaves it as a 0. So you can see you got to be, there's another function that checks if it's convertible to an integer, which I think you might need to use first. And then you can convert it with this. Oh, that's all fine. That's fine. That'll be, so this will return 128. If we didn't do that, so if we just did, for example, this, my bet is we'll get some garbage. Well, it just can't, okay, DCC won't let us add an integer to a string, right? They would be incompatible. They're incompatible types in that sense.
So in that function, if we throw in a bunch of random letters and numbers, we just ignore all the letters.
No, it's not able to convert it. Whoops. It's always going to be 0, I'm pretty sure. Oh, now it'll be 1. Okay. Whoops. Anyway, it seems undefined to me. So that's yeah. Oh, yeah. So this could be from input from the terminal. You mean from scanf? So this is a string. Yeah, so we can do that pretty quickly. So printf, enter a 3-digit number. No, but in this case, you would just do %d from the scanf. So you wouldn't need to convert it. You might mean from argv, for example. That would be a time when you do need to do this. Well, you can scanf an integer, right? We've done that. But if this was actually like int argc, if this was like this, and then we wanted to convert the second parameter, then we could do this, right? So we could do like, for example, argv of 1. So this will take the string argument, convert it to an integer. then we add 5. So if I do that, that should be 10. Yeah. Where's the camera? Oh no, the camera's there.
Like if we take any random string, what it could obviously what it will say.
So what A to I does is it looks like it will silently convert any string to an integer. But if it's not a logical string, it's going to return something that's sort of undefined. So you could see sometimes it was returning 0, sometimes it was returning the first numerical character. What would be better to do is to check that the string is something that makes sense to convert to an integer first. And I can't remember it off the top of, do either of you remember it? The function to check if a string is convertible to an integer? That didn't work. So there's these functions, is digit, is number. So you can check, is a string only made up of digits? Then you convert it first. Then you convert it. So there's some techniques there you can do. How is argv of 1, 5 in this case? Because I'm passing in 5 here. This is argv of 0. This is argv of 1. Any other questions? Jay? Sorry, can we keep the noise down a little bit? Say it again. Command line arguments are always arrays of character arrays. So it is a string. Good question. Oh, the question was 5 is already a number. Why do we need to convert it to an integer? But command line, this is a string. This is one string, and we know it's a string because the type here is an array of character arrays, which is the string. Sorry. Guys, can we keep the chatter down, especially while we get questions? That's a great question. Yeah. So the question was, if I have here argv1, which represents this string. What happens if I do, for example, that, right? That's your question? If I put, well, what I was going to do is show you this. So what do you think this would print? Who thinks, someone yell, now you can yell out. What would this print? You said 5. I'm not going to say anything. Who said 10? I think 10 is right. You think it's an error? What? Now I'm confused. Wouldn't that be 5? Oh, I didn't compile it. Everyone be quiet. Thank you, whoever. Oh, I didn't save it. I'm pretty. Okay, because it is a character, not a string. Because it's an array of characters. So when I get argv of 1, I get an array of characters, which is the string 50. When I access the 0th element, I am accessing that 5, but it's not an array of characters, it's just a character. But ASCII to integer needs a string, not a character. Yeah, how would we do that? How would I convert this character to a string?
What if you just use argv10 minus the ASCII value of 0?
Yeah, I think that's what I was more. Sorry, Tim. Oh my god. Character to int. Oh my god. Oh, okay. Tim was right. Subtract the value of the quote 0. That'll get the integer though. Oh, and we don't pass it to the function.
So instead of printing out the carry,
Either way, it's
Yeah, that gets it straight to the int. Yeah, yeah. Anyway, yeah, you could also cast it. There's a few things you could do here to get this into an integer.
Will the double brackets, double square brackets from argv always access the kind of element of the second argument?
This will always access the 0th element of the first argument, which would always be the second thing.
Would be the second character.
Yes. No, it's always going to be the first character. Yeah. I know I'm not repeating the question, but the answer should explain the question, hopefully. Okay, we're getting a bit off topic here. Anyway, I think you all get the idea of what tools we have available to us. Oh my god, too many slides. All right. Oh yeah, and then we have for loops. I think you've seen me use them a little bit before. For loops are a really common way of reducing the amount of lines of code needed to do a counting while loop. So far, most of the times I've done a while loop is having int I equals 0 while I is less than something I++. This is such a common pattern that the for loop is designed to allow us to do this basically on one line, right? So you initialize I in the for loop, semicolon, condition, semicolon, post loop action, I++. So these are completely equivalent lines of code. Right? So if you ever see a for loop, it is just a while loop mechanically. That's true. That is a difference, right? So the question, well, it wasn't a question. The statement was that in this example, I exists outside the scope of while, which is true because it's declared before the block. In this case, I is only accessible within the block. That's right. Yep. Which is probably safer in a way because it means that it's self-contained, and then once that for loop ends, I is no longer accessible.
so if I is self-contained in that block, wouldn't that mean like if you want to generate I through like an array or something, we have to figure something out?
If you want to, you're asking if you want to use I after the for loop, basically?
In a while loop, we like pass I to an array to cycle through an array and have a value. So
Oh, you can still do that within the for loop block. So anything you do with I in this block, you can do with I in the for loop block. But what we're saying is after the block, I is gone. If you really wanted to persist it, you would need to create another variable and assign it I at the end of the loop. But then you might as well just use a while loop. Okay. Okay, so your question's good. Could you create multiple integers here, for example? Is that what you're asking? So this is one of the reasons why we didn't cover for loops in this course. You can bastardize the for loop a fair bit. So you can do some pretty ugly things to it. You can change this to be different. Like you can do I plus equals 2, and you can loop it through every second element. That's not too bad. You can do things like create multiple variables, but once you start doing stuff like that, we don't recommend it. This is nice and simple like this. Don't, keep our for loops safe. For loops are always 3 parts. That's correct. Initialization or the pre-loop action, the loop condition, and the post loop action. Yeah. So the question was, can you change the amount you increment by? And yes, the answer is yes. I just sort of said that. So you can do I plus equals to 2, for example, which is not too bad to do. Sometimes you do need to do that. But anything else you should, I don't know, be careful. You can do some funky things with a for loop.
same thing like with scanf? Because it deletes the variable.
Yes, you can do things like that. So you can have for scanf of something. Yep.
How weird can we make that for?
You can do lots of weird stuff with the for loop, but we don't want you to. Okay. I thought for the last 25 minutes we can revisit Connect 4. Does that sound good? Did anyone see the announcement I put up last night? Good chat. Whoops. So here's Connect 4 that we wrote last week. I cleaned up the program on the weekend and I got it working. So do you want me to run through the changes I made and then we'll keep going? So let me just compile it and run it. So it's a little different now. So enter the column. If I enter in 1, you can see it drops down to the far left column. If I enter 2, it drops down into the second left column. And you can also see that it's clearing the terminal every time. So it's really nice and clean. 3, 4, and then we get a win detected. If I quit that and run it again, 1, 1, 1, 1, win detected. That's good. And then I actually can't check that I got the diagonal working because you can never do it with one player without winning on horizontal or vertical. So we kind of need to add the second player to test that. All right, what changed in the actual code? So nothing really big changed. We're still storing state in the same way. I've got this crazy line here, which clears the terminal every time we draw the game board. So it means we're drawing to an empty terminal state. No, don't ask me to break this down. I don't know why it works. I don't know how it works. It's just a fairly portable way of clearing the terminal. On Windows environments, there is a function called clear screen, I think, or clear, but I don't think it's portable, so I don't think it works on like what I mean is there's a Windows only header file that lets you call a function called clear that clears the terminal, but I don't think it's portable. So I don't think it works on every Unix system. Yeah, this will work on your code too. Yeah, on VLab definitely. It might not work in absolutely every case. It's a what is a regex? Is this some sort of regex? No, you don't know. I don't actually know how this is working. It's just escaping some character to get something. So Musical Wizard said, so Jake said we don't use for loops in the course while looking at for loops in the course. Ha ha ha. No, so before I used to teach the course, for loops were completely banned, and then I actually don't think they're so bad. So sometimes I lightly reintroduce them. So you're not banned from using them, but we still go with our while loop first commentary. Okay. So that printing the game board otherwise is identical. Reading input is exactly the same. Okay, something else I did is I broke down the checking for vertical, horizontal, and diagonal into 3 separate functions. And I didn't check it in a loop. So I think it was just overly complicated to loop through and then loop through 4 times to check for a win. So I just manually hard code the offset 1, 2, and 3 times. And I think it makes a lot of sense. So you pass in the game board and you just go through. One thing with this approach though is that I loop through until 3 from the end of each column or row. Because if you're 3 from the end on your board, right, you don't need to check. Is this making sense? I don't have a whiteboard marker. Does anyone happen to have one? You do? Do you want to throw it? I'll duck. It's all right. This is good training for me. Black, please. Oh, I've got some here. Don't worry. Sorry. Tim can throw it. You can throw it. Okay, throw it. You got to beat Tim's throw. Go. Just don't hit anyone in the audience, please. That was... All right, thank you. Okay, so if we've got our game board, Tim's on the camera. Yep. How are we going to do this? 1, 2, 3, 4, 5. Was it? How many columns was it? 6 or 7? 7. 7. 6. So the idea here is that if you're, so we're going through and we want to check for 4 that are all the same piece, right? So you can start here and check 1, 2, 3, 4. You can do here and go check 1, 2, 3, 4, right? So you can do that all the way until here. But at this point, there's no point checking because there's no 4 over. Right? Does that make sense? So I just looped until 3 from the end and checked the next 4. So that'll check if a row or a column has a full row or full column. So that's checking horizontal. We also, okay, there's the diagonal checks, which are the exact same idea, but you can see that the offset's a little bit more complicated. And you got to check both diagonal options differently. So this diagonal is different from this diagonal. Someone said add some comments, probably a good idea. I wrote this really quickly last night. And checking vertical, yep. And so you're checking for a win function is, the nice thing about breaking it down into the 4 functions is that checking for a win is really simple. Like this is like very clean to me. Check vertical, check horizontal, diagonal, diagonal. Now, it's not efficient whatsoever. We're looping through many times here, but a connect 4 grid is 6 by 7, which is really small. So even if we're being inefficient, we're still really fast. It doesn't matter. If connect 4 grids could get massive, then we might need to think about optimization. And everything else is exactly the same. So that's our game. Cool. So now what we can do is add the second player. Yeah? All right. So how would we do this? I haven't really thought about it. So yeah, player 1 position. I guess we're going to need a player 2 position. Would also be just reading player input. So yeah, I guess so. So let me think about this. No, because you've got to do them one at a time, right? So you can't do both at once because you need player 2 to see what player 1 did. So we might just need a variable that toggles between 0 and 1, for example, to determine whose turn it is. Or I don't think we need to create a struct. That might overcomplicate it. Any ideas online, feel free to type them out as well. We're doing this together. I think we're just going to do a Boolean variable to determine, to flip through whose turn it is. Yep. So we can say here's a turn counter, 0 is red, 1 is yellow. So if turn counter is equal to 0, it's red turn, else it's yellow turn. And then at the end of the loop, we can basically say if turn counter is equal to 0, turn counter is equal to 1, else so this will alternate it. So if it was 0, make it 1, else it'll be 1, make it 0. So this will flip between 1 and 0. We could do that. Yeah, we could do a mod or something like that. But this is fine. It keeps it a little bit simpler. All right. So if we're here,
E1 falls into the red circle. E2 falls into the
hold on. So let me just think here. So I think we want the maybe what we do is we only need one input variable, player input. So we read the player input. So we always want to do that. We always want to do that. We always want to check that it's valid. We always print the game board. Oh no. Oh no, here's what we need to do. So if it's a valid placement, if it's the 0 return, we go red, if else we do yellow. Then we print, then we check for a win. All right, let's just see what that does. So if I remember correctly, yellow should be 2. Whoa. What's going on here? Oh, am I not doing player input in the loop? Was that in the loop previously? There we go. Well, that's broken. But at least it's alternating now. All right, so why is that doing that? Play input is okay. Anyone got any ideas? Let me cancel that. If I go 1 there, then I go 2 there. So that works. If I do 2 there, that works, that works, that works. So it looks like if I put too many in one column and then I put something, it's missing, it's skipping over.
You need to set roast checks and done roast minus 1.
In the loop. Yeah. Yeah, I must have accidentally moved that. Before, yep. Yes, that makes sense. But turn counter should initialize before, that should initialize before. I thought that was working just fine before. Okay. Now at the moment, it's only ever checking that red wins. So let's try and get a diagonal actually going. So if I do 3 is 2, then 3 is 1. This is confusing now. I want 4. Yay, that works. Okay, cool. All right, so all we need to do now is test for red winning and also test for yellow winning. And then if we've got, oh, we won't have time. I wanted to do something cool, but Okay, all right, so when we test for a win, check for a win here, we need to check for what would be a cool way of doing this? So we check horizontal, vertical. Okay, over here, we check that they're red. I mean, a lazy way would just be to call these twice and change out red each time. Yeah. Pass it in? Yeah, I think so too. All right. So every time we have a check, we're going to pass in, for example, red. That didn't work. Yeah, I guess we can do that. Okay, that means each of these this is getting a bit messy here, needs an enum cell state piece to check, and this red needs to change to piece to check. Then we just call check for win with red. Red win detected. I guess an else if. Whoops. Because I'm assuming you can't have both people win at the same time. Else. All right, any issues with this? Let's have a look. Line 158. Have I got one too many? Yep. All right. Yay. Red win detected. And it's an else if, I guess, so yellow will never get the thing. I guess we can test for yellow. So we do 1, 2, 3, 2, 3, 2, 3. Yellow win detected. Good. Cool. I mean, that's a pretty rudimentary Connect 4. It's got 2 players, checks them for the win. What I was going to do if we had time, which we don't have time, is to actually print the red in actual red. Did you want to see that really quickly? All right, quickly. C printf as color red. So there's another really funky, here we go. Oh, that's not a bad, we can do that. Some hash defines there. And then what do? You do printf. Okay, so let me get this a bit smaller. Okay, quickly, print game board. Printf, this is printing it. So what we're going to need to do here is say if the game board is equal to red, we printf red. Is that right? Really? Oh yeah, okay, red. Oh, because it is a string, yeah. else if it's yellow, else, oh, I need the reset. Where do you do that? Here? No space, no comma? Sorry? Oh. Oh, and same with yellow. All right, moment. That is yellow. This is hard to see. Anyway, you get the idea. It is yellow. Like it might be not possible to see on the projector, but on my screen it looks more yellow. And then there you go. That's like pretty cool. And then actually, if you think about it, we have SplashKit, which we're using as an extension stage to do graphics programming. So you could actually make an actual graphics Connect 4 with tokens and stuff like that if you're very keen. Anyway, that's us. Tammy is giving the lecture on Wednesday on pointers, really important topic. There's the lecture feedback QR code and everything. Thank you for coming, and I will see you. No, I won't see you for a while because next week is a midterm break. Yeah, so I'll see you the week after.